Welcome to section 4.5, isosceles and equilateral triangles. Isosceles triangles are common in the real world. You can frequently find them in structures such as bridges and buildings, as well as in art and design. The congruent sides of an isosceles triangle are its legs. These are the legs right here. And the third side is the base. This is the base. The two congruent legs form the vertex angle. And the other two angles are the base angles. Let's talk about Theorem 4.3, the isosceles triangle theorem. It says that if the two sides of a triangle are congruent, then the angles opposite those two sides are also congruent. So if segment AC is congruent to segment BC, then angle A is congruent to angle B. So let's prove the isosceles triangle theorem. And to do this, we're going to need to draw an auxiliary line, which is what this dotted red line is, segment XB. We're given that segment XY is congruent to segment XZ, and that segment XB bisects angle YXZ. And we need to prove that angle Y is congruent to angle Z. So let's start off with a piece of our given information, and that's that segment XY is congruent to segment XZ. And since segment XB bisects angle YXZ, by the definition of the angle bisector, we can say that angle 1 is congruent to angle 2. The reflexive property of congruence allows us to state that segment XB is congruent to itself, segment XB. And now we can say that triangle XYB is congruent to triangle XZB because of the side angle side postulate. This side is congruent to this side is congruent to itself, and we have congruent included angles. And finally, we can say that angle Y is congruent to angle Z because corresponding parts of congruent triangles are congruent. So now let's talk about Theorem 4.4, which is the converse of the isosceles triangle theorem. It states that if two angles of a triangle are congruent, then the sides opposite those angles are congruent. That simply means that since angle A is congruent to angle B, then segment AC is congruent to segment BC. So for problem 1, we have two questions that involve using the isosceles triangle theorems. Question A says, is segment AB, which is right here, congruent to segment CB? And then it wants us to explain. Well, since angle C is congruent to angle A, then segment AB must be congruent to segment CB by the converse of the isosceles triangle theorem. So the answer to question A is yes, segment AB is congruent to segment CB. Question B says, is angle A congruent to angle DEA? And of course to explain as well. Well, using the smaller triangle right here, we're going to say that since segment AD is congruent to segment ED, then angle A must be congruent to angle DEA by the isosceles triangle theorem. So the answer to question B is yes, angle A is congruent to angle DEA.